Hello friends, welcome to Susan and John MathTube. Today we are going to continue our discussion on the topic rank of a matrix. In the last two videos, we learned what is rank of a matrix. We learned about the elementary row transformation and elementary column transformation. And finally, we learned about the normal form. We learned how to reduce matrices into normal form to find the rank of a matrix. But today I'm back with another method, and that is called the echelon form. Yeah, it sounds a little bit weird, but the spelling is Echelon, echelon form. Okay, so echelon form is basically an arrangement. It's an arrangement which is common for the people in the army. It's a military arrangement, and also in the navy. You'll be able to see people arranged or the ships being arranged in parallel rows, but one will be slightly towards the side of the other one. Or you can imagine it's kind of like step formation. So today we will learn how to reduce our matrices in this format. So point number one, only row operations are allowed. You're not allowed to talk about columns. So the most important point is column operations are not available. So you're allowed to perform ERT but not elementary column transformation. Okay, and the method is very simple. Make the first element 1, and then you convert all the elements beneath 1 into zeros, just like we did in normal form. And then you don't have to care about these elements. Look at the element diagonally, or you find the element which is non-zero in the second row. Convert that element into 1. Again, you make all the elements beneath 1 0. You keep on doing this till you reduce the matrix into the echelon form. I already told you what is echelon form. You'll be able to see a step. So write one question. So the first question is, find the rank of the matrix by reducing it into echelon form. So we have the matrix over here, 1, 3, minus 2, 1, and the second row is 1, 1, 1, 1. Third row being 2, 0, minus 3, 2, and the last row 3, 3, minus 3, 3. Okay, so as before, the first thing to do is to give it a name. So let's call it A. Now I hope all of you are ready with your pen and paper. So let's start. So remember, the method we learned in the last video is called normal form or canonical form. There is one more form, normal form or the canonical form. In normal form, we are allowed to use both elementary row transformation and elementary column transformation. And today we are going to try this with echelon form. And in echelon form, what you do is you use elementary row transformation, and don't even think about the column transformation. This is not allowed. And our aim is a matrix in which you'll be able to see the echelon arrangement. Okay, so as before, the first element, that is A11, should be converted into 1. But it's already 1, so we saved one step. Now transform all the elements beneath this to zeros. So as before, I'm going to put our equivalent sign, and then I'm going to write the plan outside. And I told you in the last video, if you want to create zeros below this one, we'll be using the row transformation. So look at this, my target element is in the second row. So I'm going to write R2 changes to R2 minus R1. Because I know 1 minus 1 will give me 0. Now my next target is in the third row. So I'm going to write R3 changes to R3 minus 2R1. And finally R4 changes to R4 minus 3R1. So here we go. So there is no change in the first row. So I'm going to write 1, 3, minus 2, 1. Now the second row is going to change and the operations are over here. So 1 minus 1, that will be 0, 1 minus 3, minus 2, and then 3, and then 0. Now remember, the operation is different. So you have to subtract 2 times this. So 2 minus 2, and then minus 6, and we have minus 3 plus 4, that is plus 1, and 0. And you can try the last one by yourself. Okay, that's it. So look at this. We have the first element being 1, and all the elements beneath that 1 are now transformed into 0. Now what we do is, we will move diagonally. Look at this. When I move diagonally, I can see the element minus 2. Now remember, if this element is equal to 0, then you go for the next non-zero element. I'll repeat, in case this element is equal to 0, you just move towards the next non-zero element in the same row. Anyway, we have the diagonal element being minus 2. So I'll plan for the next operation. So I'm going to write, look at this, my target element is in the second row. Remember, in echelon form, you're not allowed to use column operation. So I have only one option. So I'm going to write that R2 changes to R2 into 1 by minus 2. So the second row is going to change. So there is no change in the first row. And the second row gets divided by minus 2. That is minus 3 by 2. And 0 by minus 2 is 0. And the other rows will remain the same. 0, minus 6, 3, 0. Okay, so look at this. We have 1 and all the elements below 1 are 0. Kind of like diagonally, we have 1. Now our job is to convert all the elements beneath this 1 into zeros. So let's write the operations. So look at this. My target is in the third row. So I'm going to write R3 changes to R3. I'll write plus because I know minus 6 plus 6 into 1 will give me 0. And my next target is in the fourth row. So I'm going to write the operation. R4 changes to R4 plus 6 R2. So the first row will remain the same. The second row will be the same. And the third row will be changed. That is R3 plus 6 R2. So minus 6 plus 6. And then look at this. You can use the calculator. You can do this in your mind, or you can just write on one side. So look at this. The target element is 1. So 1 plus 6 into minus 3 by 2. So this and this will get cancelled. So 1 minus 9, that is minus 8. And the next element 0, 0, 0. Now it's going to be minus 6. Okay. So look at this. The first element is 1. All the elements below that 1 are zeros. Diagonally we have 1. And all the elements beneath that are zeros. Now again we move diagonally into the third row. Anyway, this is a non-zero element. If not, you find the first non-zero element in the row and transform that element into 1. So I'll go for the next operation. So look at this. My target is in the third row. So I'm going to write R3 changes to R3 into 1 by minus 8. So I'm going to use the operation R3 changes to R3 into 1 by minus 8. So there will be no change in the first row. The second row also remains the same. And the third row 0, 0, it becomes 1 and 0. And the last row minus 6 and 0. So take a look at this. The first element is 1 and beneath we have zeros, and again diagonally 1, beneath zeros, diagonally 1. So my job is to make this 0 using this 1. So I'll write my plan. So my target is in the fourth row. So R4 changes to R4 plus. I can write up to this because the target element is negative, and I know minus 6 plus 6 into 1. So that means plus 6 into the member in R3. Okay. So first row as such, second row as such, third row also same, and finally 0 plus 6 into 0 plus 6 into 0 and 0 and 0. Now look at this. If I move diagonally, I can see 0, and there is no other element than this. So that means we have reached the last step. So look at this. I'll draw something for you. I think you're able to see this arrangement. So we have reached the echelon form, and now one very important thing, you should never get confused. So look at this, 0 row. So remember, if someone tells you 0 row, then it means all the elements in the row should be equal to 0. And if someone tells you non-zero row, then at least one element in that row will be non-zero. In echelon form, the rank is defined to be the number of non-zero rows. So you're going to find the number of non-zero rows. I'll repeat that once more. 0 row means all the members in a row will be equal to 0. And non-zero row means at least one element will be non-zero in a row. So look at this. The first row, clearly that is a non-zero row. And look at the second row, again a non-zero row. Look at the third row, it is a non-zero row because there is one non-zero, at least one non-zero element. But the fourth row is a zero row. So how many non-zero rows do we have? 3. So I'm going to write rank of A. I gave that name earlier when we started this. So rank of A is equal to 3. I hope you understood echelon form. Anyway, let's try one more question and make the concept clear. And this time, let's go for a really big matrix. So, are you ready with pen and paper? So, please write the question. Find the rank of the matrix by reducing it into the echelon form. And all these questions are from your past year's question paper. Okay, so you can copy it. 1, 0, -5, 6. The second row, 3, -2, 1, 2. And then 5, -2, 1, 2. The fourth row, 5, -2, -9, 14. And the last row, 4, -2, -4, 8. So let's start. So what's the first thing to do? Let's give it a name. Let A is equal to. So look at this, 1, 2, 3, 4, 5. It's a 5 by 4 matrix. Okay, so what's the first thing to do? Yeah, you go for the corner element. Anyway, the corner element is already 1. Now what's the second thing to do? Convert all the elements beneath this into zeros. So we have to convert all these things to zeros. So let's write the operation. So R2 changes to R2 minus 3R1, and then R3 changes to R3 minus 5R1, R4 changes to R4 minus 5R1, and finally R5 changes to R5 minus 4R1. So the first row will not change. So let's try the same elements. And from second row there is change. So 3 minus 3, need to be a bit careful. So 0. Now there is no change. And then 1 minus minus will be 15, that will be 16. And then 2 minus 18 minus 16. Okay, if you want, you can pause the video for a minute and you can try writing all the transformed numbers by yourself and check the answer. And then 0 minus 2 minus 16, 0 minus 2, 16 minus 16. We have transformed all the elements beneath 1 into zeros. Now what should we do next? Yeah, move diagonally, or you can just go to the next row, find the first non-zero element. So that's a better way to find who's going to get transformed into 1. So look at this. Just move to the next row and find the first non-zero element. So my target is in the second row. So tell me what to do. Yeah, R2 changes to R2 into 1 by minus 2. So that means the second row will change. So 1, 0, minus 5, 6, 0, 1, minus 8, 8. And then let's copy the same thing over here. So let's move on to the next step. And what we do is we have to convert all the elements beneath this 1 into zeros. So my target lies in the third row, the fourth row, and the fifth row. So I'm going to write the operations. R3 changes to R3 plus 2R2. R4 changes to R4 plus 2R2. And R5 changes to R5 plus 2R2. So I'm going to get 1, 0, minus 5, 6. And then 0, 1, minus 8, 8. And then 0, of course this will be 0. And 26 minus 16. And that's going to be 10. Minus 28 plus 16. And that is going to be minus 12. And then 0, 0, 0, 0, because it's a double 2 times, minus 2 times that. Okay, so look at this. We have 1 and all the elements beneath 1 are zeros. And again we have 1, all the elements beneath this are 0. So what we do is we move diagonally, or the better method is you just jump to the next row, find the first non-zero element, and that is 10. Now you have to convert this element into 1. So my target element is in the third row, and since I'm doing echelon form, I have only one option, that is row transformation. So I'm going to write R3 changes to R3 into 1 by 10. So 1, 0, minus 5, 6. And then 0, 1, minus 8, 8. 0, 0, 1. And that will be minus 12 by 10. And that is 6 by 5. And 0, 0, 0, 0, 0, 0, 0, 0. Okay, I'm going to claim that we have reached the echelon form. The reason is 1 and then we have zeros. Look at the next row. The first non-zero element is 1. Beneath it all are zeros. Now move on to the third row. The first non-zero element is 1 and all the elements beneath it are zeros. Now move on to the fourth row. There is no non-zero element. So clearly we have reached the echelon form, and if you want to see those steps, it's right over here. I'll just adjust it. Yeah. Okay, so tell me how many non-zero rows are there. So the first row is non-zero, the second row is non-zero, the third row is non-zero, but the fourth and the fifth are 0 rows. So in echelon form, rank is equal to number of non-zero rows, and in this question, it's equal to 3. So I'm going to end this video right here. So I hope you understood the concept of echelon form. So look at this. In the last 2 videos, we learned how to reduce matrices into normal form so that we can find the rank. And in this video, we learned a very powerful method that is called echelon form. This method is more faster than reducing matrices to normal form. Anyway, I'll be back with the next video in which we will learn how to apply echelon form to solve system of linear equations. And if you find this video useful, then like, share with your friends and subscribe. And if you have any doubts regarding the topic which we discussed today, please feel free to ask in the comment box below, or you can mail me in my mail address. So I'll be back very soon with the next video. So till then, bye.